Let me do one more integral. I think I'm making my way through a prepared board here. Let's see. Good. So the integral of the tangent is minus log cosine. I'd also like to know what the integral of the secant of x is. And I don't know a way to go straight at this, but let me show you a way to think your way through to it. If I take these two facts, tangent prime is what it is, and secant prime is what it is, and add them together, I get this fact, that the derivative of the secant of x plus the tangent of x is, well, it's the sum of these two things, secant squared plus secant tangent. And there's a secant that occurs in both of those terms. So I'll factor it out. And that gives me, I'll put it over here. There's the secant of x that occurs in both terms. And then in one term, there's another secant. And in the other term, there's a tangent. So that's interesting somehow because this same term appears on both sides of this equation. Let's write u for that secant x plus tangent of x. And so the equation that I get is u prime equals u times the secant of x. I've just made a direct substitution. Just decide that I'm going to write u for that single thing that occurs on both sides of the equation. So u prime is on the left, and u times secant of x is on the right. Well, there's my secant that I was trying to integrate, and what it tells you is that the secant of x is u prime divided by u. Just divide both sides by u, and I get this equation. U prime divided by u, that has a name. I'm not sure that Professor Jarrison has used this in this class, but u prime over u, we've actually used something like that. It's on the board right now. It's a logarithmic derivative. It is the derivative of the natural logarithm of u. Maybe it's easier to read this from right to left. If I want to calculate the derivative of the logarithm, well, the chain rule says I get the derivative of u times the derivative of the log function, which is 1 over u. So often u prime over u is called the logarithmic derivative. But it's done what I wanted because it's expressed the secant as a derivative. And I guess I should put in what u is. It's the secant plus the tangent. And so that implies that the integral, integrate both sides. That says that the integral of the secant of x dx is the natural logarithm of the secant of x plus the tangent of x. So that's the last line in this little memo that I created that we can use now for the rest of the class.